Hello there. Today, we will explore various options for trench wall shoring when using the open cut method for laying utility networks. Shoring of trench and excavation walls is done to ensure safety. First, such shoring protects people working in the trench from a soil collapse. A person buried under collapsed soil, even if they do not sustain any injuries, may lose their life due to suffocation from chest or throat compression, as well as from soil particles entering the airways. Second, it prevents people, structures, equipment, and vehicles in the collapse zone from falling in. In my work, I have not infrequently witnessed terrible and absurd accidents on construction sites. Almost all of them occurred due to personnel neglecting safety regulations. Therefore, I strongly urge you to be meticulous about safety compliance on your sites. Excavations up to 1.25 meters deep can be made without shoring the walls. In dense, stable soil, an additional 0.5 meters can be dug by creating a 45-degree slope at the top of the trench. Thus, the maximum allowable depth of trenches and excavations without wall shoring is 1.75 meters. All deeper excavations without slopes must be shored along the entire working length. Before starting the work, the following tasks must be completed. Obtain all necessary permits for the work. Carry out site leveling and fencing. Perform axis surveying, and identify and expose existing underground utilities in the work zone. And the first option for trench wall shoring with the open cut method we will explore is temporary trench wall shoring using steel pipes or rolled profiles. Steel pipes are used as shoring for trenches up to 4.5 meters deep, and for trenches up to 8 meters deep, I-beams are combined with I-beam braces and steel pipe struts. The depth of embedment for pipes and I-beams is verified and refined during the calculation. The choice of shoring option depends on the height and depth of the trench. At the same time, the temporary load on the failure prism is assumed to be 2.0 tons per square meter. When shoring trench walls with steel pipes, they are installed in pre-drilled boreholes. Boreholes are drilled using drilling rigs mounted on a truck. The spacing and depth of boreholes for steel pipes are determined based on the physical and mechanical properties of the soil being developed and the depth of the future trench. If the trench is shallow, the pipes can be driven in with an excavator bucket. If necessary, high-frequency vibratory hammers and vibratory pressing units can be used to embed the pipe to the design elevation. When driving pipes into pre-drilled boreholes, the machine with the attachment is positioned along the pipe axis or perpendicular to them and sequentially drives the pipes to the design elevation by applying vibratory forces. Excavators and cranes can be used as base machines for suspended vibratory hammers. Pipes are driven in by vibratory pressing units due to the simultaneous application of vibratory forces and vertical loads. Soil excavation for the trench is carried out after the steel pipes are embedded on both sides. Excavation within 2 meters of the side surface of existing utilities must be done manually after shoring and in the presence of the utility owner's representative. During excavation, when existing utilities are exposed, they are protected with a wooden box and suspended. As the soil is removed from the partially excavated section of the trench, braces and struts are installed. Planking is installed in layers of 500, 1,000 millimeters from top to bottom, in sections equal to the distance between 2 adjacent embedded pipes. Planks are cut to size equal to the distance between the axes of the embedded pipes, plus 200 millimeters. To install the plank, a groove is made with a height equal to the width of the plank and a depth equal to the thickness of the plank. The plank is inserted into the groove, placed behind the pipe, and installed in the design position. The next type of temporary trench shoring structures is prefabricated panel shoring systems. The following types of prefabricated panel shoring systems are used: box-type panel shoring and slide rail shoring. Box-type panel shoring consists of steel, aluminum, or composite panels braced together with struts. They are used at depths of 2 to 4 meters, with a working trench width of 1 to 4 meters. The panel length can range from 2 to 5 meters. The installation process for box-type shoring is shown in the simulation you are now seeing. The first step is to excavate the soil to a depth of 1,000 millimeters to place the lower section of the box. Then, the first panel is placed on the prepared flat surface. The struts are then installed in the designated locations and secured with pins and cotter pins. The second panel is positioned parallel to the first one at the height of the struts, using a loader, crane, or excavator. The free ends of the struts are attached to this panel. After this, the entire assembly is turned so that the panel blades are at the bottom. The assembled structure is lowered into the pre-excavated trench area. By alternately pressing the excavator bucket on the upper parts of the panels, they are embedded into the soil to the required depth, with simultaneously excavating the soil. Trench slide rail shoring is made of steel and used at depths of 5 to 7 to 8 meters, with a working trench width of 1 to 7 meters. The panel length can range from 4 to 5 meters. The installation of slide rail shoring is carried out as follows. The guides are placed with the grooves for the roller element facing upward on a flat, hard surface. The roller element is then inserted into the guide groove. Next, the roller element is moved along the guide until it contacts the lower stopper. When the roller element is securely seated in the center of the guide, it is locked with a special locking element. Now the roller element is fixed to the guide. The installation of other guides is carried out in the same way. The strut extensions, inserts, are installed as follows. The insert is lifted and lowered onto the end of the roller element, and then everything is bolted together. Slings are attached to the special lugs. If the trench width requires several inserts, they are first connected on the ground, then lifted and lowered onto the end of the roller element. Before installing the panel in the ground, a small depth cut needs to be made. The cut length should not exceed the length of the segment. Once the main panel is placed in the trench, it should be pressed and slightly supported with the excavator bucket or rested on the ground. The H-shaped strut is then lifted to the appropriate height and lowered into the trench so that the panel fits into the outer groove of the guide. Then the second main panel is installed into the guide on the other side. It should slide along the outer groove of the guide. Next, both panels are aligned parallel to each other. The second H-shaped strut is installed similarly. After that, additional panels can be mounted. The guides have 2 parallel grooves for the panels, the inner ones closer to the center of the trench and the outer ones closer to the edges. Panels are first installed in the outer grooves on both sides of the trench, then in the inner ones. More detailed information on prefabricated panel shoring systems, including drawings and diagrams, can be found on the manufacturer's websites. In my opinion, the use of prefabricated panel shoring systems is economically justified if the contractor's order portfolio includes sufficient volumes of work for more than 1 year of continuous operation. Our lecture has come to an end, and I would like to thank SBH Tiefbautechnik GmbH for the video materials about prefabricated panel shoring systems. In the next video, I will continue to discover the methods of trench and excavation wall shoring in open cutway construction of engineering networks and structures. Thank you for your attention. All the best to you. See you soon.